Okay, so now what we want to do is find the integrated term for n equals 3. But unfortunately, we know this is going to be a geometric series. We know that to go from here to here, we're going to be using a ratio. All right. So what we need to do is we're going to use the formula. So our formula says a sub n equals a sub 1 times r raised to the n minus 1. But our problem is, for a geometric sequence, we don't have r, do we? No. So what we're going to have to do is we're going to have to plug in our values to be able to determine what our r is. So I do know what a sub 1 is, and I do know what a sub 4 is. So I can say a sub 4 equals a sub 1 times r to the 4 minus 1. And then can I plug in values for a sub 1 and a sub 4? Yeah. So a sub 4 is 27 over 4, lovely fraction. A sub 1 equals 16, and then r to the third power. Now that we have it written like this, is it possible to solve for r? Of course it is, ladies and gentlemen. Let's divide by 16. Remember, dividing by a number is the same thing as multiplying by its reciprocal. So I'll just multiply by the reciprocal on the top and bottom. That means that goes to 1. This gets over to 27 over 64. So we have 27 over 64 equals r cubed. Now, to find r, we need to take the cube root of both sides. So then we just need to say what number multiplied by itself 3 times gives us 27. What number multiplied by itself 3 times gives us 64. And now we know r, so now we can find the nth term. So we have a to the third term equals a sub 1, which is 16, times our r, which is 3/4, raised to the 3 minus 1. So then we have a3 equals 16 to the 3/4 squared. Well, 3/4 squared is the same as just 3 squared over 4 squared. So then we have a to the 3 equals 16 times 9 over 16. And then we notice that this is a numerator, denominator. Those are going to divide into 1. So our third term, a to the 3, just equals 9. Questions? Good?